Welcome to Get Your FRQ On. This question is from 2022. It's question 6, and it is not calculator active. In the question stem, we have a particle P moving along the x-axis for time t greater than 0. There is a function x sub p of t that gives its position. And we have a second particle Q moving along the y-axis for time t greater than 0. And for particle Q, we have a velocity function v sub q of t. We're also told that at t equals 1, the position of particle Q is y sub q of 1 equals 2. In part A of this question, we are asked to find the function v sub p of t that gives the velocity of particle P at time t. Since x sub p of t is 6 minus 4e to the negative t, all we have to really do to find v sub p of t is differentiate that function. When we differentiate, we get v sub p of t equals 4e to the minus t. In part B of the question, we are asked to find a sub q of t, the acceleration of particle q, and then find all t greater than 0 for which the speed of particle q is decreasing. We're given that v sub q of t is 1 over t squared. This implies that the acceleration of particle q at time t is the derivative of v sub q of t, which is negative 2t to the minus 3. Whether the speed of particle q is increasing or decreasing is going to depend on the respective signs of v sub q of t and a sub q of t. The speed of particle q will be decreasing when v sub q of t and a sub q of t have opposite signs. One thing to note is that by definition, v sub q of t is never going to be less than 0. So v sub q of t is always greater than 0 for all values of t. And a sub q of t is less than 0 for all positive t. And a sub q of t is greater than 0 for all negative values of t. However, we're not concerned about negative values of t here. Therefore, we can conclude that the speed of particle q is always decreasing since we're really only concerned about values of t greater than 0. In part C of this question, we are asked to find the function y sub q of t, which is the position of particle q at time t. The function y sub q of t can be found using the fundamental theorem of calculus. Y sub q of t is going to be y sub q of 1 plus the integral from 1 to t of v sub q of x dx, which is 2 plus the integral from 1 to t of 1 over x squared dx. So y sub q of t is equal to 2 plus the integral from 1 to t of 1 over x squared dx, which is 2 minus 1 over x evaluated between t and 1, which is t minus 1 over t plus 1, which is just 3 minus 1 over t. In part D of this question, we are assuming that t is approaching infinity and then asked which particle will be farther from the origin as t approaches infinity and to provide a reason. So for particle P, we look at the limit as t goes to infinity of 6 minus 4e to the minus t, which is 6 minus the limit as t goes to infinity of 4e to the minus t, which is 6 minus 0, or just 6. For particle Q, the limit as t goes to infinity of 3 minus 1 over t is 3 minus the limit as t goes to infinity of 1 over t, which is 3 minus 0, or just 3. And since 6 is greater than 3, As t approaches infinity, particle p will eventually be farther from the origin than particle q. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.